This is the operation of the circuit. So now let us assume we are giving the supply voltage VCC. So we turn on the power supply. So based on the doping levels Q1 and Q2, we assume Q1 is turned on at first. So let us assume Q1 is on first. So if it's on, it means, so we have a short circuit between collector and emitter. And this is the base. So if there is a short circuit means what? So it means we already cleared the blockage, that is the depletion layer. There is no more depletion layer here. So there is a current conduction is going on. There is an current flow. So it means whatever this VCC is coming here, it will go to this node and then it will just go to the ground. So because of this, the current or the voltage level at this node maybe we can call this as a O1, that is the output one. So at this node, the current level is almost zero, or the voltage is almost zero because the current is flowing to the ground. So because of this, okay, now we will see one by one. It means Q1 is in the saturation region. Q1 is in the saturation region. It means collector and emitter are short circuited. So now VCC will go to ground and output O1, this is the output O1, is logic low. So the logic low means, let us just forget this graph. We will make our new graph. So now the output is logic 0. Okay, this is 0. Okay, so now what is happening now? At the same time, this O1, this is the logic 0, right? O1, this is 0 volt. So this 0 volt is what this 0 volt is doing now. It drives the base of Q2. This 0 volt is driving it, just traveling through this path, and then it will go and then drive the base of Q2. So if you apply very small voltage in the base or almost the 0 volt in the base, then what will happen? So you cannot turn on this Q2. The Q2 will be in off condition, right? Because you need to apply the base voltage above the threshold voltage in order to drive this transistor. So now you are applying almost 0 volt here. So this Q2 is off. Here Q1 is on because it's short circuited here. And here Q2 is off, and we can call this is a open circuit. So now you should note down one point. So since this one is open circuited, there is no current flow between this collector and this is the emitter. And of course we have the base here. Because of the base voltage, this is open circuited. So what is happening now? So whatever the voltage we are applying, the supply voltage, it has no path to go to the ground. So this will accumulate here and at this node O2. So the voltage is getting more and more higher at this node. So okay, let us say the voltage level is high. So the output of, we will delete this graph and we will make our new graph now. So here the output is logic 1 now. Okay, so this is what I mentioned here. Where is the, yeah, at the same time O1 drives the base of Q2, so Q2 remains off and capacitor C1 is charging via R1 by VCC. So when this is happening, at the same time the capacitor C1 is getting charging. So it's charging. You know, capacitors and inductors, yeah, C and L, whenever you apply some kind of voltage or when the current flows through it, it will not charge immediately. It needs some time to charge fully. So once it charges completely fully, then it will start to discharge the charges. That is the property of capacitors and inductor. So capacitor is storing the electrical current in terms of charges. Inductor L is storing the electricity or the electrical charges in terms of magnetic field, electromagnetic field. Okay, anyway, we are not going to study about inductor in this circuit, so we don't need to think about this. The capacitor. So the capacitor is charging this VCC and storing the charges, and then once it's fully charged, then immediately this will start to discharge the charges. Now let me change my color. So after it charged fully, this voltage will start to drive the base of Q2. So this one is already high voltage. So now this is not a 0 volt anymore. So maybe this is 1 volt, for example, let us say. So this 1 volt is driving, this is more than the threshold value. So then what will happen? So you are giving more voltage to this base. So then instead of open circuit, this will be on. This Q2 will be on, then this will be short circuited. So if it's short circuited, then there will be a current flow. Now this Q2 is instead of off, Q2 is on. And because of on, of course, there is a short circuited between collector and emitter. Then this VCC will go to this node, and then from this node, and then it will go to the ground. Because of this, the voltage level at this node O2, this is the node O2 or the output 2 terminal. So voltage at this node will go to logic 0. So now this will become logic 0. So now you see, because this transistor is on, so the output is becoming 0. This is the graph. And now what's happening now? So because this is the, now it's a 0 volt, right? This is 0 volt. This 0 is driving now, the base of this Q1. So it means this, we are applying the 0 volt to this base. Then what will happen? This 0 volt cannot maintain blocking the or melting this depletion layer, right? So then this transistor will go to off immediately. You need to apply the base voltage to certain level in order to maintain on condition. Now you are applying 0 volt from this path to the base of this Q1. Because of this, the Q1 is goes to off. When the Q1 is goes to off, then what will happen? So here is the open circuit. There is no current flow between collector and emitter of this Q1. So since this is the open circuit, then what is happening? So this voltage VCC will come to this node O1, and it will accumulate. So it will become high voltage. So it will become logic 1. So now remember, this Q1 is off and Q2 is on. So because of this off, we have open circuited. So this voltage is accumulating here. So we get logic 1 at the output. So at the same time, now this C2 will be charging from this VCC. So and then C2 first, it will charge slowly. So let us say it will charge slowly, the capacitor. So until it's charging, this position will be maintained. This will be off and this will be on. This is Q2 and this is Q1. Q1 is off. So once this C2 got fully charged, then what will happen? This fully charged will drive the base of this one, the Q1. Then this will be, it means this will be 1 volt, and then this will drive this. Then there will be a short circuit, and immediately then the current will flow down, and you know that this is the third cycle. This Q1 will be on, and then once it's on, then there will be a short circuit. This high voltage will travel to the ground, then this will become 0. So now again this one will become 0, and this one is on. And here you can remember, since this is on, this voltage is 0, and this 0 will drive this one. Now this Q2 will be off. So this will happen alternatively. So let's see here. After C1 is fully charged, it discharge and drive the base of Q2. Drive the base of Q2. It's more than 0.7 volt. That is the threshold voltage VT. Now Q2 is on. Now Q2 is on in this one. So when the Q2 is on, it means the collector and emitter got short circuited. Then VCC goes to the ground, and then the output O2 is logic low now. So that's what we mentioned here. And now O2 is, this O2 is equal to 0. This O2 is equal to 0, right? Logic 0. Then this drive the base of Q1. Then the Q2 will go to off. Now this O2 is equal to 0, drive the base of Q1 via C2. Then now the Q1 is equal to off. Because of this off condition, now the output of Q1, such as O1, is logic high. At this node, O1 is logic high. So this will happen alternatively. So what is happening here now? This transistor will be on. If Q1 is on, means Q2 must be off. And if Q2 is on, means Q1 is off. So it's alternatively. And this is really based on the time required to charge this capacitor C1 and C2. So this C1 and C2 is alternatively driving these two transistors base, and then based on this on condition or off condition, then we get the collector voltage either logic high or logic low. So that is why we call this is a astable multivibrator. So here we are not giving any trigger pulse. So this is staying in logic 0. After some time, this is immediately goes to logic 1. So this stays in logic 0 until this C2 becomes getting charged, fully charged. And then it goes to logic 1. And then it stays in logic 1 until C1 gets fully charged. And then it goes back to logic 0. So this is happening alternatively. This is the operation of this astable multivibrator. So maybe I try to explain one more time. So here you can see we are applying the VCC, and whenever you apply the VCC at the first time, initially we assume Q1 is on, Q2 is off. Q1 is on means there is a short circuited, so this collector voltage will go to the ground. So the collector is becoming 0 now. At first step 1, Q1, Q2. So at the first step, we assume Q1 is on, Q2 is off. Q1 is on, Q2 is off. If it's on means there is a short circuit. So this collector will be 0 because this collector current will just directly go to the ground. So here the output of this one, or let's say like we need to have one more column, I think. Let me say step 1. And then this is the Q1, and this is the collector of Q1. This is the output. This is the output 1. And this is the Q2, transistor Q2. And this is the collector of CQ2. This is the output 2. This is the output 2. So we have 4 columns now. So at the step 1, what we are doing, we assume Q1 is on and Q2 is off. Q1 is on, Q2 is off. Because of Q1 is on, this whatever the voltage comes from the VCC, it goes to the ground. So here the voltage is 0. The output 1 is 0. And here the Q2 is off. Because of this is open circuited. The voltage will accumulated from this VCC to this node. So here it will be logic high. So that is 1. So in the meantime, this C1 is charging. So once this C1 is fully charged, then this will drive this base of this Q2. Then Q2 will be on now. So in the second step, let's say this is the step 1 and then the step 2. So now Q2 is on because of the C1 charge. So if this Q2 is on, then it means there is a short circuit. Then whatever the voltage accumulated here from this VCC, it will go to the ground. So here, then because of that, the voltage level will go down. So it will be logic 0 now. So the output at this output at the collector of Q2 is 0. Output as the collector of Q2 now it becomes 0. Okay. Now what is happening? This 0 is driving the base of Q1. So Q1 is off now. Since Q1 is off, so here it's open circuited. So the voltage will accumulated from this terminal to here, and then it will be getting more and more high. So it will be logic 1. So here it's logic 1. This is step 2. And the step 3, what's happening? At the same time, this C2 is charging. So now the C2 is charging, and after it becomes fully charged, it will discharge its charges. And then that discharging voltage will drive the base of Q1. Now Q1 will become on again. This is the Q1, right? So now the Q1 will become on again. Once the Q1 is on, short circuited, then this voltage will go down to the ground. Then this will become logic 0. So this will become logic 0. This logic 0 will drive to the base of Q2, and then the Q2 will automatically go off because the base voltage is less. Because of this off, then what will happen? There is open circuited. So the voltage VCC will accumulate in this point, in this node, and then this will become logic high. This is so the collector output is logic 1. So this is the step 3. So this will just continuously happen automatically. So as a result, if you plot a graph, then it will be like this. So it will be one time for short time, it will be 0, and then it will be 1, and then it will be 0, and then it will be 1. So it's like that. That is a stable multivibrator. So if you look at the waveform here, you can see it very clearly, the same thing. So here you can see this is the Q1 collector, and the Q1 collector is logic high. At the same time, Q2 collector is logic 0. So in the meantime, we are charging the capacitor, and then the capacitor is fully charged. Then it will drive the base of Q1, right? The base of Q1. This is the base of Q1. So once you turn on the base of Q1, then what will happen? If you turn on the base of this one, then there is a short circuited, then this will automatically go to 0, output of this Q1. So this is why we can see here the output of Q1 is 0. And then the capacitor is finished, and then now we are charging the other capacitor the next cycle. So this will just repeat again and again. So this is also the same for the Q2 base. So here the base have a high voltage, base have the high voltage, then it means this one Q2 is on. Q2 is on means then there's a short circuited. Then short circuited means this voltage will go to the ground. Then this will be the logic 0. So can we check now? So this is the logic. This is the base of Q2. Yes. And this is the collector output. So this is the logic 0. So if you look at the graph, it's very obvious based on the theory. So this is the operation or working principle of this astable multivibrator. You should remember, whenever we give the base voltage, this will be on. If we give the very small base voltage, this will be off, or 0 voltage, the base will be off. So if it's on, then there will be short circuited, the current will go to the ground. If it's open circuited, the current will stay here, or the voltage will accumulate, and this will become logic 1. So this will happen alternatively based on the charging and discharging of C1 and C2. So this charging and discharging is based on this R1 C1 value, R2 C2 value. This is called time constants. This is a little bit tricky. You shouldn't get confused. If you know the operation, that is why I explained the device physics in the beginning. So whenever you apply the base voltage, you are making the conduction, you are making the short circuit. If you don't apply the base voltage, or if you apply 0 volt in the base, then it means you are not making the conduction between these two terminals. So you are making either open circuit or short circuit between this terminal and this terminal. This is the emitter and this is the collector based on the base voltage. So whenever you make the short circuit, then whatever the current you apply, then that will flow. So this is what we are using here.